All right, let's go over some midpoint distance and completing the square because we're going to learn about conic sections, which you've actually learned about them before. Circle is an example, a parabola, learn about other conic sections. And before we learn about them, we need to just review some algebra skills. So the first one is finding the midpoint and distance between 2 points. So, there's a midpoint and distance formula, which you can use and just type right into your calculator. All right. If you don't have a formula, if you don't know the formula for whatever reason, you can always just kind of sketch a picture and do it that way, like by using either. So let's do the distance first. And for the distance, you can always use the Pythagorean theorem. So you move 5 to the right, down 7. So that'd be one of these points. Oops, I gotta let someone in the Zoom. All right, and then the other point would be at -2, 1, so somewhere around there. Okay, so I'll show you how you can type this right into the calculator. But like I said, if you have to do this without a calculator, to find the distance, you can create a right triangle where this is the hypotenuse, and then kind of move vertically then horizontally from one point to the other. So from 1 down to -7, we're moving down 8. And then from -2 to 5, we're moving across 7. So this hypotenuse here of this right triangle is also the distance between these 2 points. So x would equal, well, x squared would equal 8 squared plus 7 squared. So if that's x squared, take the square root of both sides, we get that x is equal to the square root of that. So it's the square root of 64 plus 49. So 64 plus 49, that would be 113. And I don't think that simplifies. So that would be your answer if it said write it as an exact answer. Now, a lot of times with distance, you could put it as a decimal. So in that case, you would just use the calculator. So the distance formula, which I'll show you in a future slide, you can type it right into the calculator. The calculator is not turning on. Don't know why. Oh, there it was. Cancel, come back. Oh, someone else is joining class. All right, no idea. Sorry, I'm gonna skip the calculator part for now. I thought I had that open, but it just won't open. Class where you just stare at a blank screen. All right. So when that comes up, I'll show you to do that. Now for midpoint, you could just, it's the point in the middle. So add the x's, divide by 2, and add the y's and divide by 2. So I don't have that picture, it's gone. But if I were to draw that picture again, then the midpoint would be on that line directly in between the two endpoints. To find the location of that middle point, do the midpoint formula. So average the x's, average the y's. All right, now the calculator wants to come on. So you'd get 3 over 2, so like 1.5 for the x coordinate, and then -3 for the y coordinate. All right, and that's how you do midpoint. So you can sketch a picture if you forget the formula, or just use the formula. That's the formula for midpoint, average the x and y's. For distance, subtract the x's, that gives you, like if you think of the Pythagorean theorem, that gives you one of the legs. And if you subtract the y's, that gives you the length of the other leg. And then x2 minus x1 squared plus y2 minus y1 squared would be like doing a squared plus b squared. That equals c squared, the hypotenuse. So then that's how you remember to take the square root, because you want c or d, the distance, not d squared. All right, and then one other thing is that you should know how to do, probably did this in geometry, is given an endpoint, find, and a midpoint, find the other endpoint. So you could use the formula and do it algebraically, but I think this is easier. So if this is an endpoint, so I'll call that E for endpoint. And then this would be a midpoint, 5, 1. Okay, so that's that point, and that's the other point. So we have to find the other endpoint. So I know if this is one half of the line, then the other half of the line would look like that if M is a midpoint. So that point's going to be somewhere over there, probably below the x-axis, not 100% sure. But to find the coordinates, we can kind of use this picture and just kind of count. So if from -3 to 5, that's +8. So you go from one end to the middle by adding 8. Well, to get on the other end, you would add 8 again. And so 5 plus 8 is 13. So that's like your other endpoint. All right. And then like 6 to 1, you go down 5. So that's one end to the middle is down 5. So to keep that point in the middle of the two endpoints, you would go down 5 more. So 1 minus 5 is -4. So, that's another way to find an endpoint, given a midpoint and an endpoint without using the formula, just by sort of counting. And what I'm doing is I'm using, like, if you look at this picture, I'm using the idea that the midpoint divides that line into two equal parts. So to go from one end to the middle, we go like right and up, and then that creates a triangle. And if we do the same thing, we go right and up the same amount, that would create the other half of the line being equal to it. So like side, 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 those two triangles are congruent. So that's the midpoint. All right, and then last but not least, completing the square. So this, first I'm going to go over how to solve an equation by completing the square, but eventually leads to like being able to write this in standard form, because this, believe it or not, is actually the equation of a circle. But it's hard to tell because it's in like a weird form. So we're going to learn how to complete the square. Same way we complete the square to solve an equation, to write this in a standard form of a circle so you can see what the center and the radius is. So first, quickly review what it is to, like, how to complete a square when solving. So first, when you complete the square to solve an equation, get your x's on the same side. So I'm going to add x squared to both sides, and then leave that 5 over on the right side. Now, completing the square is actually where the quadratic formula comes from. If you ever want to prove the quadratic formula, you take ax squared plus bx plus c equal to 0, and then complete the square, and you'll get the quadratic formula. So how do you complete the square? Well, you're trying to rewrite this as like a quantity squared, so a perfect square, so that you could take the square root of both sides. Now, every perfect square trinomial, meaning something that could just factor to like x plus something squared, or it's like the same binomial times itself, is in the following form, all right, where this last term here is half of b squared. So half of 6 is 3, divided by 2, and squaring that gives you 9. Now, any trinomial in that form where it's 1x squared plus some number b times x plus that same number b cut in half squared, like half of 6 is 3, squared is 9, it's always going to factor to like a binomial squared. In this case, it's x plus 3 squared. So it's always going to factor to like x and then like half of b. Now, this is a perfect squared trinomial, which means it factors to like like x plus 3 times x plus 3. Something that could factor that isn't a perfect square trinomial would factor something like x plus 3 times x plus 4. All right, so what's special about this, it's the same factor times itself. Now, you also have to add it to the right side to make, because, it's an equation, it's got to stay equal. And now you could solve this by taking the square root of both sides. So you take square root of both sides, and then subtract 3, and you get x is equal to -3 plus or minus, because we took the square root of root 14. Now, this part here, we're not going to need to do for going forward. It's just flashback to algebra 2. But what is important is this step, how we went from this trinomial to something being squared, because that's what we want to use when we write the equation of a circle. So the reason why that worked is, let this represent like x squared. So it's an x by x square. And then 6x, right? If we put 3 1 by x rectangles here, and then 3 of them here, so like that big square is x times x, so the area is x squared. These are all rectangles that are 1 by x, so they each have an area of x, because like length times width, 1 times x. So like these three would have an area of 3x, and these three would have an area of 3x. So where does the term complete the square come from? It comes from this picture, like this visual representation of this x squared plus 6x, and it looks like a square that's not complete. So like what's missing? Well, it's this part, and this part would have an area of 9 because it's a 3 by 3 square. Because see, like this side here was 3, and that side there was 3. So if you represent the area as the sum of like these four parts, like x squared plus 3x is 6x plus 9, right? That's where this comes from. And then instead of expressing it as the sum of those four parts, you can also express it in terms of its area, like x plus 3 times x plus 3, which is nicer to do that because now it's being squared, like over here. You can take the square root of both sides. So that's why we do half of b squared, because you can imagine like these 3 by x pieces here and here, like there was 6x, we cut it in half and put like 3 on one part and 3 on the other part. And then this part was like 3 times 3, 9. So that's why we do half of b squared. That's like kind of like a visual of that. All right, if you just remember half of b squared, that's all you need to know. All right, so now, last but not least, we did that already. All right, rewrite this equation by completing the square. So we want to put it in circle form, like standard form of a circle. So when we complete the square, first, let me think for a second. I think I messed up these numbers. Whatever, we'll figure it out. So first, when we complete the square, we want to get rid of the leading coefficient in front of, well, first let's group together our x and our y's. So before we get, let's just make it nice. So we'll do 3x squared plus minus 18x, and then leave some room, and then plus 3y squared plus 24y, and then leave some space, and then subtract 7 on both sides. Okay, never mind. That was good. There was no mistake. I was doing something wrong. All right, so first, just put it, so we're trying to get this in standard form of a circle, and I'll show you, you'll see what that is in a second. All right, so we want to complete the square like here and here. So first, we want to get rid of that coefficient of 3. So we want to, whenever we complete the square, like we did at first, like we had a 1x squared. So we want a 1x squared and a 1y squared. So we're going to divide everything by 3. So the next step is going to look like this. It's going to be x squared minus 6x, leave some space, y squared plus 8y, leave some space, and then equals 11. Okay? So now we're doing what we did before. We solved the equation by completing the square, but we're doing it twice. Once for x, one for y. Because we're not actually solving anything. We just want to rewrite this. So now what do we do? What do we have to put here to make this a perfect square trinomial? All right. It's got to be half of b squared. So half of 6 is 3. 3 squared is 9. So we add 9 there. All right. But then we also have to add 9 here. And then this, well, half of 8 is 4, squared is 16. So add that there, add that there. Okay, now we can take this part and rewrite it as x minus 3 squared, which is awesome because you'll see in a second that now we know if this is a circle, this tells us where the center is. All right, then we could take this part, because it's a perfect square trinomial, right? This half of that squared is that. That would be, so there's still a plus sign here. That would be plus y plus 4 in parentheses squared. And then this part here, 11 plus 9, that's 20, plus 16 is 36. All right, that's just 36. And we're done. Going forward, we're going to see that this is a circle. And if you remember from geometry, this would be a circle with a center at 3, negative 4. And this is actually equal to the radius squared. So the radius is equal to 6. We'll do a whole lesson on that. For now, we're just worried about getting to the red step. All right, now that the square is complete the square, we can, it's way easier to tell that center and radius than from this step. So by completing the square, we're putting it in standard form. So that's it. So we could do more examples, but let me pause this video.